Have you ever stopped to think about how your computer can have a perfect, error-free conversation with a server halfway across the world? Especially when the internet itself is, well, kind of chaotic. It all comes down to a very polite, very precise digital introduction. Let's break down how that essential first step really works. So this is the big question, right? The internet isn't a perfect, stable wire. Messages can get lost, they can show up in the wrong order, they can even get duplicated. So how in the world do you build something certain and reliable on top of all that chaos? The answer lies in a really clever set of rules. Think of it like digital etiquette for building trust. To really get it, let's look at two ways you can send a message. First, you've got something called UDP. That's kind of like tossing a message in a bottle into the ocean. You send it off and, just hope it gets there. But for things that absolutely have to arrive correctly, like loading a web page or sending an email, we use something called TCP. Think of TCP as being more like a phone call. You make sure the other person is actually on the line and listening before you start talking. And that brings us to the hero of our story, TCP, which stands for Transmission Control Protocol. Now, a protocol is just a fancy word for a set of rules that computers agree on to communicate. Without them, you could have two devices connected, but they wouldn't have a clue how to talk to each other. TCP provides the rules for a reliable conversation. So what is TCP really? At its core, it's all about a few key ideas. It's reliable, which means it guarantees your data gets there in one piece. It's connection-oriented, meaning it sets up a dedicated line before any real data gets sent. And it delivers what's called a byte stream. So if your data is like a bunch of separate letters, TCP acts like a scribe, putting them all in perfect order, creating one continuous scroll for the other end to read. No fuss. Let's dig into those characteristics just a bit more. Reliable delivery is huge. If a piece of data gets lost in transit, TCP notices it wasn't acknowledged and just sends it again. Simple as that. Connection-oriented means it doesn't just start shouting data into the void. It politely asks to start a formal connection first. And that byte stream idea? It just means that applications don't have to worry about chopping up and reassembling data. TCP handles all that messy work behind the scenes. Okay, so how does TCP actually set up that connection we've been talking about? Well, it uses a process that is so elegantly simple and yet incredibly powerful. It's known as the three-way handshake. It's like a secret, super fast greeting that happens before every single reliable conversation on the internet. This image here shows you the whole flow of that digital conversation. On the left, you've got the client, that's your computer, and on the right, the server you want to talk to. It all kicks off when the client reaches out to say, "Hey, you there?" The server responds saying, "Yep, I'm here and I hear you." Finally, the client sends one last confirmation, and only then is the connection fully open and ready for business. Let's break down those three steps. So here they are, laid out nice and simple. Step 1, the client sends a message called a SEN. Step 2, the server replies with a SYN-ACK. And step 3, the client confirms with a final ACK. You can think of it as, hello, hello back. Okay, got it. It's that simple, powerful sequence that makes so much of what we do online possible. So what do SYN and ACK actually mean? Well, they're basically little flags inside the TCP message. SYN stands for synchronize. Its whole job is to kick off the connection and get the sequence numbers between the two computers in sync. And ACK, as you've probably figured out, stands for acknowledge. It's the simple thumbs up that says, "Yep, I got your message." Now, all of this seems pretty logical, but it does bring up a question. Why 3 steps? Couldn't we just do it in 2? A request and a reply? Well, it turns out that third step is actually the most important part of the whole dance. Exactly. Why bother sending that final confirmation from the client back to the server? The server already said it was ready to chat. What does this final step really accomplish that the first 2 don't? Okay, here's the crucial part. That final ACK confirms to the server that the client is also ready, and importantly, that it heard the server's reply. Without it, the server would be stuck in a half-open state, setting aside resources for a connection that might not even be real. This third step makes sure that communication can happen reliably in both directions. That's a full duplex connection, and that both sides are fully committed. This is also why it's a target for attacks. Bad actors can send a flood of initial requests, but never send the third ACK, forcing the server to hold all these half-open connections until it just gets overwhelmed. This might all seem like some really low-level, geeky detail, but this handshake is happening constantly, just beneath the surface of everything you do online. It's pretty much the invisible foundation of your digital life. Seriously, this handshake is happening all the time. Every single time you load a web page, a handshake kicks it off. Sending an email? Handshake. Downloading a file from the cloud? You guessed it, another handshake. It's the silent, reliable engine making sure your data gets exactly where it needs to go, all in one piece and in the right order. This quote from the source material really just nails it. You can physically connect two computers with a cable. But without these agreed upon rules, these protocols like TCP and its handshake, they're just two machines sitting there in silence. The handshake is what turns a connection into a real conversation. So the three-way handshake is just a beautiful piece of engineering, isn't it? It's a simple, elegant solution to the really complex problem of creating reliability out of unreliability. And it makes you wonder, what other amazing invisible protocols are out there, quietly making our connected world possible every single day?